So let's look at some arithmetic and logic operations. So we have some operations here, as you can see. For example, first one is add. So add, what it will do is it will add the value of the T2 plus T3 and store the result inside the register T1. Okay, so here you can see the result. T1 equal to T2 plus T3. We can actually use for example, the same register. We can use, for example, T2 equal to T2 plus T3. We can do that as well. Another one is subtraction. So in this case, T1 will be equal to T2 minus T3. And then we can do the AND operation, OR operation. Also, we have the XOR operation. I'm not going to put everything here. These are just some of the operations that we can perform. So, and this is AND operation bitwise. So this is OR operation bitwise. I hope you remember what is AND, what is OR operations from our last semester subject. Okay, and then we have the sum of the logic operations, for example, set if equal. So which means that if T2 is equal to T3, then T1 will take the value of the T2. Same here, set if less than. So for example, if in this case T2 is less than T3, then T1 will be equal to T2. This is just the less than or equal. Okay, so these are the sum of the logic operations. Okay, so let's look at the some example for this one as well. So let me open this one. Okay, so right now our data part is empty. We don't have any data. We are just using the instructions here. So let's go step by step. What's happening here? I have the first registers T0 and I'm loading the value of 2 inside the register T0. And then I'm loading the value of 4 inside the register T1. Now let's do the addition. So what I'm doing is T2 will be equal to T0 plus T1, right? So this is the addition. There's also a command called the add immediate. Add immediate, what it will do is it will add some integer value to the register that you show. So in this case, as you can see, the second part is instead of the register, we are showing the just integer number. Okay, so this one is we use the add I, add immediate. So you can actually type add I here and you can see how it works here, right? So add I means in this case it will add this second value to this register and store the result in the first register. Okay, so next what we are doing is a subtraction. So in this case what we are doing is T0 is equal to T3 minus T2. In this case we are using again the subtract immediate. In this case what we are doing is T1 equal to T2 minus some integer value, in this case integer equal to 25. So let's go through this first. So let's do the addition and subtraction and see the results. So I'm gonna run this and we're gonna do the step by step. So first we're gonna load the decimal 2 into the register T0. So if I execute this, as you can see here, T0 becomes equal to 2. I execute the next line, T1 becomes equal to 4. So the next we're gonna do the addition. So addition, we're gonna add the T0 plus T1 and store the result inside the T2. So I'm gonna execute. So as you can see, the T2 becomes equal to 6. So 4 plus 2 is equal to 6. I execute the next line. In this case, we do the minus. So T3 minus T2. Okay. So in this case, the value of the T3 is equal to 6 and the T2 is equal to 4. So is it 4? So let's see. Let's look at the subtraction. So T0 is equal to T3 minus T2. So let's execute this one and see the result. Yes, this is the result equal to 4. So 6 minus 2 equal to 4. And we can do the subtract immediate in this case from the T2. What is T2 here? T2 is equal to 6. We are doing the 6 minus 25. So execute this one. And let's see the result. So this is the result in a hexadecimal form. Okay, so T1 now equal to 6 minus 25. Okay, so let me stop it here for now. Okay, so this is how we do the addition. Okay, so now also we can do the multiplication here. So this is the multiplication part. For multiplication, I'm reading the new values. T4 is equal to 40, T5 is equal to 20, and then I'm doing the multiplication. So T6 equal to T4 multiplied by T5. This is division, so T4 divided by T5. And also, we have the multiplication for the large numbers. So that one, we have the operation called mult, M-U-L-T. In this case, what happened is that sometimes, if you look at these registers, I forgot to mention, these registers, if you look in a hexadecimal form, right? So if you count the number of, as you can see, digits here, we have the 8 digits. So each digit, this is hexadecimal form. If we have the 8 digits, which means the one register can hold the 32 bits of the data. But what will happen if, let's say, that we are adding or multiplying certain numbers? So in this case, we are using the multiplication, and then our result is bigger than 32 bits. What will happen in that case? In that case, our number will be divided into two parts, and the one part will be stored inside the register called high. So you can see at the bottom there is a register called high, and another part will be stored inside the register called low. So if our data is longer than 32 bits, in this case the two registers will be assigned to hold the single value. So our data will be divided into two parts, and then the first part, first 32 bits will be stored inside the high, another 32 bits will be stored inside the low. Okay, so that's why we have something called mult. So and then we can actually read the values from this high and low using this operation. So in this case we are reading from from low and reading from high to the register T6 and T7. Okay, so let's execute this part as well. So I'm gonna run the program. I'm gonna skip the first addition part. Okay, so now we came to the multiplication part. Here I'm gonna read the 40 to the register T4. So let's execute this. So T4 is equal to 40. The 40, in this case 28 in hexadecimal. Next, I'm going to read the 20 inside the T5. So 20 is 14 in hexadecimal. Now I do the multiplication. 40 multiplied by 20. So this will be around 800, right? So let's execute this one. So as you can see, as soon as I execute the multiplication, the low is now, this one is stored inside the low. So even the multiplication, when you use the regular multiplication, they use the same methodology as a multiplication, as a MULT operation. Okay, so let's execute this one. Okay, so let's look at the value of the T6 here. So T6 is after the multiplication is equal to 320. So 320 here is in a hexadecimal is equal to the 800 in a decimal value. But okay, so let's finish this next one. Okay, so let me stop here. So we have we executed this part, multiplication, the 12 and the 13. So we are multiplicating the register T4 and then the T5. Okay, so registers T4 and then the T5, and then the result is stored inside these two registers, high and low. But then what we are doing is we are copying the value of the low inside the T6. So that's why if you look at the inside T6, it's same result as inside the low here. Okay, so low is getting the same result as this T6, and the high inside the T7, but it's already 0 because our number is less than the 32 bits. Now, with all of this, these are as you can see, there's some arithmetic operations. The main drawback is that we have to do all addition or multiplication one by one. Okay, so if, for example, we have this kind of operation, x equal to 20 plus 5 plus 2, then we have, for example, 3 different registers to hold the 3 different values. But then we have to do each addition separately. Okay, so first what we're going to do is we do this part, 5 plus 2. So what we do is T1 equal to T1 plus T2. So T1 is 5, T2 is 2, so 5 plus 2 is equal to 7, and then we store this 7 inside the T1 here. Okay, and then after we finish this one, the value of the T1 is equal to 7 now. Now we can do the 20 plus 7. Okay, so 20 plus 7. So this is done here. So we have to do the 2 separate operations. And as you can see, this is for you to understand how your computer works. So you may have the very complex problem when you create a program in a higher level languages. But in lowest level, this is how it works. Okay, every operation that you create will be divided into small and small, very simple operations like here that we can see here. Okay, so and your computer can perform the billions of these operations. So that's why, from our perspective, computers are very fast. But you have to understand, whenever you write the high-level programming, it all comes to this. Everything is done in this manner. Okay, so if you have, for example, the 100 operations here, it's not performed in one run. it performed in multiple runs. Okay, so that's why sometimes we say the single line of the code can take the multiple instructions in your computer to finish. Okay, so for example, here you can see the very simple operation 20 plus 5 plus 2, but look how many operations are involved here. 1, 2, 3, 4, 5 instructions are involved just to perform the single very simple arithmetic operation. Okay, so for this one you have to understand that's why we are actually looking at the assembly programming today. Same for this one. If you want to, for example, 5 plus 4 times 12, then we have to load all of this data inside our registers first, and then we do the multiplication part, 5 times 12, right? So this multiplication, and then we do the addition. I'm gonna upload all of these codes to the goals as well, so you can download and see them and run them. So right now, let's run this program. Let's go to the, we are interested in a lower part of our operation. Okay, so here, for example, we finished the first part, the 5 plus 2 plus 20. So 5 plus 2 plus 20, we restore the result inside the T0. So as you can see, it shows the 1B. So 1B, this is a hexadecimal value for the 27. So let's do the next, 5 plus 4 times 12, it comes here. So first we have to load all of this data inside the register. So we T0 is equal to 5 now, T1 is equal to 4, and then we read the next one. So now the T2 is equal to 12. So this is 12 is C in hexadecimal. So 5, 4, and C is now inside the registers. So first we do the multiplication. So 4 times 12, we do the multiplication. Okay, so and then it goes to the low, but from the low it will be copied inside the T1. So now if you look at the inside the T1, it shows the 30 here. So the 30 means 4 times 12 in hexadecimal, and then we do the addition. So we finish the addition. As you can see, T0 is now equal to 35. So 35 again in a hexadecimal. So this is must be the 4 plus our 30, right? Sorry, the 5 plus 30. So it shows the 35 here.